Woohoo, and welcome back. I'm back, and Sharktopus is back, and we're here with using logarithmic properties to expand logarithms. When we last left our heroes, we were using the property that talks about the log of a product becomes the sum of the logs. I know, it's fancy talk, but you can do it too. Listen again. The logarithm of the product equals the sum of the logarithms. Now, of course, I've said that twice, except these two problems are a slightly different rule, which is the logarithm of the quotient equals the difference of the logarithms. It sounds fancy, doesn't it? Well, you too can start saying things like this if you felt like it. And I'm sure you'd make tons of friends. I make tons of friends at parties when I say things like that. People are amazed and very impressed. And it's yes, I am the most popular person I know. Yes, it's entertaining at parties. Logarithms, always a big hit. So let's go ahead and work on expanding these logarithms. Now, in this case, I've got a common log. In both cases, I've got a common log. So it's log base 10. And you can see that I have rather annoyingly offered up numbers that have nothing to do with 10. So if I look at this, I've got logarithm of, and the quotient is 22 over c. Pardon me, Sharktopus. There we go. Which is equal to, and again, log of 22 minus log of c, which kind of makes sense. When these two in here are multiplied, it's the sum. When it's the quotient or they're divided, it's the difference we're subtracting. Now, why did I say it's kind of annoying? Well, it's kind of annoying because log base 10 of 22 is not anything really nice that I can do in my head. Obviously, if I were asked to, I could use a calculator to come up with approximation. This does not ask us for that. This just asks us to expand. So we've taken this and we've expanded it. And again, what's the benefit here? The benefit is almost always we're going to be trying to get as close to the variable as we can. And so here the variable was trapped inside a larger expression. Now the variable is closer to outside, right? It's still log of c. So, and again, I'll remind you, you always have this option of writing in the parentheses if it's easier to parse for you so it doesn't look like log c, log of c. Okay, so shall we try the next one? Dun, dun, dun! Do you see the exciting extra bonus I put in here? You got it. There's a multiplication and a division. Now, you can approach them from either direction, however you'd like. There are a couple different ways to approach this. Let me show you the way I would approach it, just to make it, this is the way I think of it. So I got 2c on top and 7 on the bottom. So I'm going to first split up the fraction or the rational expression in there. So I've got log of 2c minus log of 7. Now, let me point out something that's really important. It's a teeny tiny little detail, but it's really, really important. The 2 and the c have to be inside the parentheses. You must include these parentheses. Now, up here I said, you don't need parentheses. You could choose to do it or not, because 22 is not 2 times 2. It's a single number, right? 22 is a number. It's a symbol that means whatever 22 means. So you can use no parentheses or parentheses. Here, because this is a product, you have to have the parentheses in. Technically speaking, officially, if I wrote something like, I'm going to write this on a different piece of paper because I don't want it to be on our page anywhere, confuse anyone who just reads the notes. If I wrote log of 2c, that is technically c times the log of 2, believe it or not. The logarithms are just like exponents. They only see what's right next to them. So if you want to keep the 2 and the c together, they must be in parentheses. So helpful tip there. Okay, let's go back to doing the problem. So in the problem here, I've got this is multiplied, so I can go ahead and expand it a second time. I've got log of 2 plus log of c minus log of 7. So this 2c split into pieces. Oh, sorry. That came off the side of the screen. There we go. So, and you can see that you can see, anyway, you can see that I could make this a really complicated expression in here. And this might expand and just get bigger and bigger and bigger. I don't have a sound for that. I don't know how to do the opposite of yeah, it doesn't quite work. But anyway, so imagine the sound of expanding something. And, but again, what is the benefit of this? What do we ultimately get out of this? Well, again, in this expression over here, c was trapped inside a logarithm with a bunch of other things. And by expanding, I can evaluate log of 2, although I don't know it off the top of my head. And I could evaluate the log of 7. And I could calculate 2 approximations for those. And then I would be left with just this as the unknown, this as the variable piece. And so it's a way to kind of sneak closer to the actual expression or to getting c by itself. And that's usually what we're trying to do. We're usually trying to isolate the variables. So this comes closer to isolating c than this did. Okay, so woohoo, that was exciting. We had a couple of new properties. Now I've got 2 more things to show you about logarithms. You ready? I know, it's very exciting. What will it be? What will it be? Everyone was wondering, and it's going to be exponents. Woo! Oh my goodness. I know, you're really going to be popular at parties now. So, because we can expand logs of products, we can also expand logs when there are exponents. Basically, an exponent is kind of a shorthand for products. Now, it isn't quite when you think about exponents like 1/2 or -5, but it's the same idea. And it turns out we don't have to worry. That's the great thing about this class. When you're taking an algebra class, you don't have to prove any of these things. If you decided to become a mathematician after algebra, after trig, after analysis, after calculus, after diffie-qs, after all that fun stuff, you go back to the beginning. And part of learning mathematics, you prove all these things. So you go through and show why these things work. And if you can't prove it, you investigate why it makes sense and why we can make these leaps to say, if I have the logarithm of a given base, log base a, of m to the n, and I know I didn't choose these letters. Who would choose 2 letters that sound identical? I don't know. M to the nth power, then it turns out that this little n comes flying down from the exponent and goes right in front. Now this is only true if m is greater than 0 because we're trying to take the logarithm of it. So we've got some constraints there. But if you can come up with an exponent, then you can simplify a little bit. So let's look at what that means. Well, here I have common log of 1,000. Okay, fine. That is log base 10 of 1,000. You don't have to write in the 10. I find it helpful. And then I think, wait a minute, 1,000 is just 10 cubed, right? 1,000 is just 10 cubed. They're exactly the same number. 1,000. Well, they're the same value. They're not the same number. Sorry. And then if I've got an exponent, that exponent can come down in front. So I've got 3 times log base 10 of 10, right? That's this. This is the 3 that comes down in front, just like this. I don't know the sound for it. Whee! There we go. There's the sound. Whee! Okay, so then I've got log base 10 of 10. Log base 10 of 10 is just 1. So I've got 3 times 1 is 3. Woohoo! Could you have come up with this result another way? Absolutely. The really great thing about algebra is regardless of how you come into the problem, if you're using properties or theorems or other things that are correct, and you're not trying to do this in a camera, which is very difficult, no matter which direction you come in, you'll end up at the same point. Okay, let's look at number 2. I've got log base 2 of 8. Now, can I write 8 in terms of 2? I can. That's just log base 2 of... What is that? Oh my gosh, what's behind you? I see a pterodactyl. I see a pterodactyl sneaking into your room. Don't let them. Pterodactyls are always trying to steal all of our logarithms. It's terrible. Okay, pterodactyls and logarithms, you know, all those letters that we don't really pronounce. Yeah, it's all a thing. Okay, so 8 is really 2 cubed. Now, I can take this 3 down in front. And I hear you asking, wait, does this only work if the base and this base, if these two match? No, these first two I happen to pick with matching bases just to make an interesting problem, but you don't have to. So what did I do again? This exponent right there, came down in front. And then, because I happen to know log base 2 of 2 is equal to 1, just like log base 10 of 10 was equal to 1. So then I've just got 3 times 1, which is 3. Yay! Woo! Okay, let's do some more fun stuff. Number 3, log base 3 of 3 to the x. Okay. Well, in this case, I mean, this is almost easier than the previous problems. I've got an exponent. The exponent can always go down in front. So 3 to the x power, the x can come down in front. Comes down in front. I'm going to regret that sound. I can already tell it. Tell no one. We don't need to, no one else has to know, just between me and you guys. Okay, so comes down, and then, oh my goodness, look at that. What are the chances that I'd have log base 3 of 3, which equals 1? So we've got x times 1, which is x. Oh my gosh, all of these. So these first 3, they're all really the same examples. I just wanted to give you practice. Okay, y'all ready? Log of radical x. And I hear everyone saying, wait a minute, there's no exponent there. And I would say, au contraire, if I spoke French, but I don't really. So what I might say is, well, actually, is there an exponent? There is. Radical x is really just x to the 1/2 power. Oh my gosh, which I think is quel fromage in French. And so what would we do? We take that exponent and we go all the way down in front. The 1/2 comes out in front right there. And then we've got 1/2 log of x, or log of x over 2. We could always write it that way. Okay, now I hear you saying again, really, is all of this work really useful? Or are you just doing this so that we don't notice, you know, the fall of capitalism? And the answer is, well, capitalism is nowhere near falling. It's working just as it was designed to work, unfortunately. So don't worry, you're not missing anything. But what we are doing is we are practicing taking one type of logarithm and rewriting it in other ways to give you options. And so if you do go on in mathematics and if you do continue to study, we're setting this foundation so that when you get to these tough problems, and they can get really complicated in here, you have ways to kind of break it open. And here we've gotten closer to having x by itself. And this 1/2, was previously a square root, which is not going to do anyone any good. A 1/2 is just a 0.5. Easy peasy, right? So we have simplified the work that we have ahead of us. So that's the goal. It's just giving you options. Okay, dun dun dun! Number 5, log of the cube root of x. Now I jogged or logged your memory. I jogged your memory there. So tell me, cube root of x is what exponent? You're right, it's 1/3. So now what do we do? Well, we've got an exponent, and at this point I hope that you're just like, oh, exponents, get them out, put them in front. Whee! And it slides down out in front, and I've got 1/3 log of x, or, of course, just like with the previous one, I also have the option of writing it as log x over 3. So I got 2 different formats. Again, the goal here is options. The more you know about how numbers interact, you can see the shadow. I wave my arms around a lot when I'm talking, even when there's no one else here. But you see a lot about how the numbers interact and how many different choices you have when you're working through a problem. It may be that this is easier, or it may be that this is easier, and you get that choice. So woohoo, this is all about choices. Yay! Last thing I'm going to tell you about logarithms before we go on to the next section, where we're actually going to try to use some of this stuff to do something interesting, which will be fun. Fun. It'll totally be fun. But this is actually a formula that comes out of the need to calculate other kinds of logarithms. For example, in number 2, I used log base 2, and in number 3, I used log base 3. On a regular calculator, well, regular as, I don't know how long this video will last, so if you are watching this from the year, I don't know, 2080, I don't know what calculators will look like then. But right now, this is a calculator that was produced like 10 years ago at this point. But really, you've got 2 choices: common log, natural log. That's it. Now, nowadays, if you have a fancy calculator, and this is a calculator that's been around for maybe like 4 or 5 years, it turns out that this does have other options. It just shows natural log and common log, but there's actually other logarithms inside it. And if you click it 3 times, you get this option that says log base, and you can actually choose, for example, log base 2. So newer calculators and certainly computers can handle this, but we do have this formula that's left over from back when people were either calculating this on older calculators, or, believe it or not, when I started teaching in the 1600s, we didn't use calculators. A lot of students didn't have calculators that could calculate logarithms. Woohoo, we're back. Sorry about that. Sharktopus got a little bit distracted, and you know what happens. We had to make a whole movie about it. So, what I was saying was, because I was a little long-winded, was that it used to be that we calculated logarithms using something called log tables. In the back of your book, there would be a really thick section, and you would look up what logarithms were equal to. And so change of base can be really helpful for that. But it can also help, as in this example, where we've got log base b of x. Instead of everything being, again, all tightly woven together, we can unweave it, we can expand it, and get log of x up on top and log of b down in the denominator. And then hopefully that gets you that much closer to finding x or b, depending on the situation, whatever you need. Now, the really cool thing about change of base is that it even exists. If I have a logarithm base b of x, the relationship there actually gives us the same answer if we take a common log of x over common log of b, or natural log of x over natural log of b, which is really cool and surprising. So let's go ahead and find this value. So I'm asking for log base 3 of 7. log base 3 of 7. So if I go with the first one, I could use log, common log of 7. Notice I go with the bigger number. 3 is kind of down below, so we think of it as that's going to be our denominator. So log base 3 of 7 equals log of 7 divided by log of 3. Let's look how we do it here. Okay, so, oh, there's my face. Oh, that was exciting. So we've got log, and on this calculator, this one has one key to rule them all. So if you click on it once, you only get natural log. So you want to make sure you click twice, click. That gets me to log, so I've got log of 7. I'm going to close that logarithm, and then I'm going to do divided by log, and I have to go click again really fast, log of 3, close that logarithm, enter, and I get 1.7712434749, etc. And we're not asked to round it, so I'm not going to worry about rounding it. But what I am going to do is I'm going to go ahead and use the other formula, natural log of 7 over natural log of 3, because a lot of students are like, I don't think those would be the same. And the answer is they are. It's pretty cool. So this one, a little bit easier. I'm going to use just natural log, which on this calculator is a single press. Natural log of 7 divided by natural log of 3. And in both cases, notice you have to close the parentheses, hit enter. Oh my goodness, it's the same thing. By which I mean the same answer. Woohoo! So you can use log, you can use our common log, you can use natural log. If you have other logs on your calculators, you can go bonkers. Like I said, it's a party. Everyone loves logarithms. You guys, we have made it through 9.6. Woohoo! And in our next section, we're going to go and use all these properties to do much more exciting and interesting things. Woohoo! I know, you can hardly take it. So go get some rest, go get some oxygen, go get some fresh air, some vegetables, hydrate, be gentle with your brain, and, play a little, make a little art, and know that you're awesome. And I will see you guys again. Woohoo and math on.